So if you didn't email me your homework, you need to do that now. Um, okay. So do that now. Yeah.
Did you have my email?
With your homework? I saw an email from you. So I wrote up on the board. Can you see what I said? Yeah. What about down lower? What did I write? Test tomorrow. Keep reading. Yes, bring your laptops. Then keep reading. It says the central limit theorem activity. That's what you just did. I said turn in now, and so like now means like now for plus 10 percentage points. But if you don't think that you're really comfortable with it, you could turn it in Friday or Monday, because I don't want to penalize. Actually, I don't know. If you are unclear and you don't feel comfortable with the assignment because it was a challenging assignment, that'll give you more time. But for those of you who were diligent and worked ahead and did like you were supposed to do and figured it out, you are rewarded with doing a good job for turning it in today.
So we get 20%.
If yeah. Okay. Questions? No. All right. Let's do some stuff in R. So like I said here, I want to talk about the central limit theorem briefly, and then we'll save the rest of class for questions or review for the test or whatever you guys want to do. Yeah. Okay. If you need to have your laptops open because you're following along, great. Otherwise, the almighty, camera can see everything, so you don't even bother going on Facebook. Yeah. What's up? It was working before, but now, yeah, I'm skeptical that it's working. Maybe you guys can keep like sliding around every now and again. So this is going to look a little bit confusing to start, but it's okay. Also, one thing, so like I never make you guys take notes in this class, but which is fine. I'm okay with you guys just listening and soaking it all in. But sometimes though, you guys ask me questions, and I'm like, man, if you were just taking notes, your life would be so much easier. So try to think about like when you're like, oh, it's appropriate just to sit here and listen, versus when like I should probably write that down because it's going to come up later, and instead of not knowing, I can just reference my notes. So you don't have to crazy write down everything I say and write, but as a good student, try to be selective as to what you do take notes on. So I said, if x is a random variable with, what does e parentheses x mean? The expected value of x equals mu of x. We should be getting, for the test tomorrow, that the expected value, it's like the mean, it's like the center of the distribution. We're cool with that. So if the expected value of this random variable is given by mu with a little subscript x, just because it's x, and the variance of x is given by sigma squared x. All I'm saying is you have some random variable, it's got a mean, it's got a standard deviation and a variance. All good. Sorry, that's an and. And x bar sub n is another random variable whose outcome is given by the average of n instances of x. So what the heck does all this mean?
Isn't that just like a really complicated way to say that, like?
Yes. Go on.
That just seems like very complicated. Essentially, it's just like x is gonna have like an out with the x sub n. I don't know what the bar means. It's gonna as just like a random variable, and it will have like an outcome where like, the expected value is a mean and the variance has a standard deviation. I feel like it's just like everything we know. It seems very like obvious.
So all I've said is you have a random variable x that has a mean and a variance, but then also there's another random variable. If something is random, like if the height of the next person who walks in the room is random, that's a random variable. Then if I take the height of the heights of the next 5 people who walk in the room and average them, average height of 5 people is a random variable. Do we follow? So instead of looking at the height of one person, now we're taking the average of multiple people's heights, and that's another random outcome. That's what we call, we've seen this before where we have like x with a bar over top of it. When you have x or a variable with a bar over top, what does the bar imply? Average. So that's why it's x bar, because it's the average of the x's, and the subscript n is just saying because it's for n instances of x. So a little brief review. What would the probability mass function of one die roll look like? When you roll a die,
Well, like for each outcome, it'd be 1 out of 6.
good. So the outcomes are 1, 2, 3, 4, 5, and 6, and those all have probability 1/6. Something very simple like this would do for a probability mass function for a graph of that. Okay? Not too bad. So I'll call this thing like D. The random variable is D. As in, I roll a die and something random happens and I get 1 through 6. What's the expected value of D?
1 times the 6 plus 2 times the 6 plus 3.
1 times the 6 plus 1/6 times 2 plus. So it's actually, if you factor out 1/6, it's just 1/6 times 1 plus 2 plus 3 plus. What's 1 plus 2 plus 3 all the way up to 6? Who can do it in their head? 21 sounds right. So this is 21 over 6. So it's 21 over 6 in decimal terms.
3.5.
That's equal to 3.5. Does that make sense that the expected value of this random variable is 3.5? Why, Grace?
We can say the mean.
Because it's what?
Near the mean, like 3 is half of 6.
3 is half of 6, but what's the mean of this random variable? Is it 3 or 3.5?
3.5.
The mean is 3.5, but so, Kyle, why does 3.5 make sense?
It's halfway
It's halfway. Keep going.
between 1 and 6.
Between 1 and 6, and between 1, 6, and what's halfway between 2 and 5? 3.5. What's halfway between 3 and 4? 3.5. This is a uniform distribution that's perfectly symmetric. It makes sense that the mean, like the balance point, just kind of splits it right down the middle. That should be intuitively okay. That the mean here is right in the middle. It's 3.5. All right. I could also, if I wanted to, find the variance of D. I'm not going to bother doing it. What do you think the variance of D is? Or sorry, not the variance of D. Let's talk about actually the standard deviation of D, because it's easier to interpret. Jacob, what do you think the standard deviation is here?
Like 3.
What's up?
3.
Okay, so what do we think about 3? It's not a bad guess.
Maybe 2, I don't know.
Maybe like 2. Felicia, how do you feel about a guess of the standard deviation being 3?
I think it's fine.
So what's the mean?
1.
3.5.
The mean is 3.5. What's the farthest you can get away from 3.5? So 6 is 2.5 units away. And remember, we should know the standard deviation roughly says, it roughly tells you what?
The distance from the mean.
The average distance from the mean. So if the farthest away you ever get from the mean is 2.5, then the standard deviation should be like less than 2.5, right? Because 6 is 2.5 away, 5 is 1.5 away, 4 is 0.5 away, 0.5 away, 1.5. So maybe it's something like 1.5, whatever, okay? Questions on that? Everett?
No, got it.
Caleb? Okay, so this is my lengthy intro to talk about a random variable D given by one die roll. So now in R, if I just want to simulate D, if I want to repeat D, I want to take lots of dice and roll them just once, what would be a good R function to mimic rolling a die? But not even a for loop yet. All we need is just a sample. So first of all, say die is equal to 1 through 6. And so if I take a sample of die, how big should my sample be? I mean, anything you want, whatever, 10. So 10 rolls. And if I hit replace equals true, this code, as you can see down here, gives me outcomes from my die roll. Except for I rolled the die 10 times. Yeah? So far we should see nothing crazy. If I replace this 10, make it 1,000, Grace, what's going to happen when I make that 10 and 1,000?
You get like 1,000 numbers with 1 through 6 repeat.
Good, I'll get 1,000 numbers all between 1 and 6. So I'm going to call this thing rolls. If I make a histogram of rolls, Felicia, what's the histogram going to look like for all those numbers?
Is it gonna be uniform?
It is going to be uniform. What does that mean to be uniform?
That, like theoretically, they all should have the same probability, so that the histogram will be of all equal lengths, because they all have the same probability.
Awesome. Good job, Felicia. So here, it's a little bit weird looking, but you can interpret that we had basically the same amount of 6s as 5s, as 4s, as 3s, as 2s, as 1s. Okay? So all I had to do was just use the sample command to roll a die 1,000 times, or 10 times, or however many times I wanted to do it. Everett, question?
No, I'm sorry.
Okay. Kyle, question?
Nope.
So I just said there, this histogram is like the probability mass function of D that we just looked at, right? But so now I want to consider a new random variable. Let's say d bar, let's say d bar 10 is a random variable. So d bar sub 10, what does that random variable mean? Felicia?
Would you just have to like find the average of rolls?
Not of rolls. So forget about this for a second. Just think about, so d is some random variable that represents what, 10?
I'm not sure.
So we just talked about d1. What's d? Jacob, what's d? I had it up here before.
Isn't it just doing die rolls?
Yeah, d is just one roll. But so now d bar sub 10, it's a random variable whose outcome is given by the average of
Rolls.
10 rolls. So it should make great sense that one roll is a random outcome, but if you roll 10 times and you find the average, that's again a random variable. Sometimes it's going to be 1, 2, 3, they're going to be a bunch of averages that we'll find. It's given by the average of 10 rolls. So hopefully we kind of followed, I'm saying D stands for die, but everything I've written down here, X, same thing, D, X. So the cool thing then is that the expected value of X bar sub n, well, we'll get to that in a second. What's the expected value of D bar sub 10? So raise your hand, don't shout it out. So remember, expected value